Hello, my name is Max Starszewski. This is my ECE314 final project. It is an AM radio receiver. Here's a brief overview of this. Amplitude modulation, or AM, is a form of radio broadcasting where the amplitude of the carrier waves modulated according to the message signal. It's one of the oldest forms of radio communication, circa 1900. And crystal radios are one of the oldest and most primitive and oldest types of radio receivers. So it seemed logical to start with them. Application to signals and systems here is pretty self-evident. My implemented radio receiver incorporates an LC bandpass filter and a half-wave rectifier that uses a low forward voltage germanium crystal diode, making it a crystal radio. I managed to capture some low frequency noise in the ECE building and managed to demonstrate some filtering using a function generator at the input and an oscilloscope at the output. I am using this design, these two designs here. I've made some small adjustments to them. I'm using an off-the-shelf variable capacitor from DigiKey. I'm using a 1N60P germanium diode. They just said use any germanium diode. That's what I could find. My coil is wound around a 3/4 inch dowel instead of a cardboard tube, just to make it more rigid, a bit more durable. I've adjusted the number of turns on my coil so that it should be the same inductance. My center frequency I've calculated it as being from about 0.5 megahertz to 1.1 megahertz, depending on the value of this capacitor. My antenna is a quarter wave monopole, the coil adjusting the ideal length to approximately 10 feet. Here's my schematic. So you've got your antenna here, you get some radio waves. This primary coil here creates a magnetic field that induces a current in this secondary coil, which is adjustable. This secondary coil will short out at low frequencies, and this variable capacitor here will short out at some arbitrary high frequency. So there ends up being a small band of frequencies where our earpiece over here is receiving some signal, and this diode here is rectifying it. This is the actual implementation, the actual circuit that I made. Here we have my variable capacitor. Here I have two diodes. I have two in series for more current, although that didn't end up doing that much. This is my output resistor. Normally I'd have my earpiece wired across this, but I was testing it using an oscilloscope. This is that primary coil from the previous schematic, and this is the secondary coil. I've filed off some of the enamel on the top of this so that I can short out part of it so that it's variable. And here I have a video of me testing it. Hello, my name is Max Starszewski. This is my ECE314 final project. It is a crystal radio. Currently I am analyzing its frequency response. I have the radio tuned to peak here at about, I don't know if you can see there, 2 volts at 470 kilohertz. If we go ahead and adjust this capacitor right here, and you can see that our voltage on the oscilloscope has bottomed out. We adjusted the capacitor. If I go ahead and adjust frequency, well, look at that. We should see, yep, our peak's now at around 390 megahertz. In addition to that, I have this wire here, which I can use to short out part of my inductor. So if we have the oscilloscope here in the background, and my wire, you can see that when I drag this across here, it
changes it somewhat. It's very noisy, but yeah. So we're peaking up there, and then I touch a little bit below here, and there we go. You can see we peak lower there. It means we're changing the center frequency of our bandpass filter. Doesn't like that a great deal because it doesn't get very good contact on this coil, but you get the idea. I'm not sure. I can try to adjust this to have it peak again. So our new resonant frequency after we're doing this is around 380 megahertz. The amplitude isn't quite as good as the last ones, but that's kind of typical for these bandpass filters. And when I take this off, go back to that, and I can readjust it back to peaking at 390.
So these are my results. The second test had the circuit grounded to a TV stand. I found throughout trying to test this that ground from the wall socket was really unpredictable and wasn't really giving me good results. File cabinets, TV stands, and metal bookcases all worked much better than ground from a wall socket. Unfortunately, I can only capture low frequency noise, and measured frequencies in that first video. The measured frequency range of the circuit was lower and narrower than predicted. It's roughly in range of 300 to 600 kilohertz before amplitude started really dropping off. My earpiece was acting very strange throughout all this. In that second video, you see me fiddling with one of the jumpers. I'm shorting out part of the earpiece to ground. For some reason, when I use the earpiece, it would work for a little bit, and then the audio from it would just slowly drop off, and I would have to periodically short it to ground to make it work. When I was testing that in the lab, I actually tried just wiring a just straight noise from the function generator up to it, and it would only occasionally output, which is rather strange. My conclusions follow from this. I'll probably next try amplified radio using transistors or just integrated circuits like op amps. I thought that would be too easy, but there are a lot more variables going on here with my antenna and parasitic capacitance that I hadn't necessarily factored in. I think my earpiece was causing a lot of issues. After finishing this, I did some research into these earpieces. They're really popular online, and it turns out that there's like a 30% failure rate to them, and that's due to one of the contacts in it being made of aluminum and just being glued on with non-conductive glue. Some surplus headphones might work better, although they're expensive. These are $50, and they only get more expensive from there. I also might want to consider investing in the microcontroller, like an Arduino. I could use this to transmit AM signals much more predictably. Could also use it to record signals from the circuit. Overall, I've enjoyed this project. It's introduced me to antennas, passive filters, speakers, and RF communication. I'm really interested in those areas now, and I'd like to learn more about them. And these are my references. So take care. Thank you for watching my video. Have a great day. Bye-bye.